Welcome to our February Planet Possible MiniPod. I'm Nikki Roach, and this is a monthly update where we react to current events in water, climate and nature. And it's a mini-pod because it'll only take about 15 minutes of your time, and it means you get a Planet Possible episode every 2 weeks. So each mini-pod, I'm joined by an environmental expert, and we explore 3 issues that are making the headlines, keeping you up to date with what's happening around the world and where my guest sees exciting possibilities. This mini-pod, my guest is Technical Director, Global Technical Authority for Water Quality and a Technical Fellow at AtkinsRéalis, and she leads a team of technical experts working on coastal and river water quality and water pollution. Dr Vera Jones.
Thank you very much, Nikki. I'm delighted to be here.
So we're talking with quite a bit of water quality focus in today's episode, which is a topic that we're seeing a huge amount of focus on in the kind of mainstream media and certainly from the general public here in the UK. Let's start by talking about emerging contaminants and specifically pet flea treatment chemicals. Tell me a little bit more.
Yeah, so emerging contaminants are an area of great interest. It's something I'm really interested in as an environmental chemist by technical background. And we have been doing a lot of projects in this area in my team, both supporting the regulators but also the water companies to explore the risks and understand the presence of a range of emerging chemicals in the water environment. And I think we have so many new ways to monitor these chemicals and detect them now in the environment. So we're finding more and more of those chemicals because we are able to detect them at lower levels. We're able to detect more of them, but we are also using more and more chemicals in our everyday lives. So I think it's really important to assess the risks. It's really important to be accurate, but also balance the risks against the benefits of using certain chemicals in our everyday life. And I think that's particularly important and quite difficult for pharmaceuticals, which can be indispensable, and in some cases there isn't really an alternative. I think the case of fipronil and imidacloprid is particularly interesting, and I think it has come to the forefront really the last few years that people have become more and more aware of them. They are insecticides that we use on pets to protect them from fleas, so they play a really important role for the well-being of pets. They are ectoparasiticides because you put them on the pet to prevent fleas from going on them. And as you would expect, they are really strong pesticides. So fipronil is a broad-range pesticide, and imidacloprid is actually a neonicotinoid. So we know that neonicotinoids can have a particular effect on bees. It's interesting how they enter our ecosystems, particularly the water environment. So they can enter our waterways either when we wash the bedding of our pets, or I suppose when dogs go and splash in rivers, or they can enter through surface water into our drains. What is being found more and more is that they are really widespread. So some monitoring I was looking at by the Freshwater Biological Association found that fipronil was present in 99% of the samples in 20 rivers that were monitored, and imidacloprid was present in 66% of rivers in the 20 rivers studied. And also imidacloprid has been found also in estuarine sediments. So their presence appears to be widespread, ubiquitous really, and we're at the stage now where we need to understand the impact they're having on the aquatic invertebrates, being in that category of pesticides, and how we can mitigate these, how we can control the sources. The British Veterinary Association has encouraged vets to make that risk assessment on a case-by-case basis, I guess, in terms of the necessity of using them. So I think more research is needed to really understand their impacts on the environment. We would expect them to have a potentially, negative effect, being such strong insecticides, and that ubiquitous presence is potentially concerning. It's important to learn more about that. It's important to be aware of that issue. I think that's really important, that public awareness. But also learning from mistakes of the past and not leaving it too late to act. So I think the scientific community, the water sector and the regulators are very much focused on understanding that better. But it's a really interesting story and something to keep an eye on and follow.
We've talked about neonicotinoids actually in a previous mini-pod in December, so it's fascinating to hear a little bit more, and I hadn't appreciated that they were in pet flea treatments. Okay, let's move on to topic 2. The topic that I wanted to share was about a study that was recently published in the Proceedings of the National Academy of Sciences, which is a University of California journal, and I'll pop a link in the show notes. I thought it was interesting because it basically reveals that human-driven climate change will, and I quote, dramatically overhaul critical nutrient cycles in the ocean, with evidence that marine nutrient cycles that are essential for sustaining ocean ecosystems are changing in unexpected ways as the planet continues to warm. And the models have predicted that when the ocean warms, it gets more stratified, and that can drain certain parts parts of the surface ocean of nutrients. And what I thought was particularly interesting was this suggests that it's the first study to confirm climate change impacts on nutrient cycles. The team looked at 50 years worth of nutrient data and they discovered two things that really stuck out. One is that there's been a major decline in phosphorus, certainly in southern hemisphere oceans, and also that concentrations of nitrate, which they thought would be declining, actually remain steady. And obviously phosphorus is a key player in the health of marine food webs. Phytoplankton become less nutritious if they're not eating as much phosphorus containing nutrients, and therefore that impacts on the food chain and the growth rates of fish. But what I thought was also really interesting about this piece was the importance of collecting good quality data, both to sort of help shape the debate with evidence, but also because in the case of nitrate, the climate models had forecast it to decline, but actually the research wasn't showing that forecast. I would love to hear your reflections as an expert in water quality with a real focus on kind of bathing waters. What did you think when I sort of shared this with you?
Yeah, this is a really interesting topic and it really sort of speaks to my heart actually, because I am an oceanographer by training. You know, the oceans are so important for our wider ecosystem and our food webs, and obviously they play a critical role in our climate as well, so there's that sort of feedback effect. So climate change is happening and it has so many different impacts and there's so much uncertainty in quantifying them, as you've alluded to. Modelling is a brilliant tool to try and understand and forecast those impacts, and I think it's given us some really important clues on understanding those impacts and being able to sort of add the granularity really to those forecasts. Nutrients, as you mentioned, are the driving force behind our food webs, our marine food webs, and in particular nitrogen and phosphorus are traditionally seen as the basis and they're sort of the foundation of the marine food web. And there is such a fine balance of the different nutrients in each different ecosystem, whether that's aquatic or oceanic ecosystems. And that balance is just so important. And anything that sort of perturbs that balance can have quite significant impacts that are very wide-ranging. So climate change can affect that stratification element, so it can make the ocean more stratified, which we know is happening, which then results to a smaller amount of nutrients coming from the deep waters to the surface waters. And it looks like the latest research does suggest that phosphorus concentrations in particular have been declining, which then can have such an important substantial impact on the wider food web in the ocean. There are also, changes to temperature we know can affect the currents and the way huge oceanic currents circulate. And that can also have a really important impact on the nutrients, but also our weather and all sorts of different other, very wide-ranging effects. The other issue around climate change on the oceans is acidification, which is another topic that has been, widely studied, and there's still a lot of uncertainty and is still being very much investigated by, the science community. We know that our oceans are becoming more acidified, so as there is more carbon dioxide in the atmosphere that is absorbed by the water, so a smaller abundance of those carbonate ions, which are really critical for some organisms in terms to sort of building their structures, and then that again perturbs that really fine balance in those ecosystems. I think with all those things, modelling is a key tool to understand them, but as you say, data collection has a critical role to play there, and models are only as good as the data that you put in. It's really important to sort of intensify efforts for monitoring, I think, throughout our natural world, and in particular for the ocean, which is such a complex, vast sort of system. Understanding better how these changes are happening, the sort of timescales, the rate at which they're happening, is really important so that we can really focus our efforts where it really matters.
I was really struck by how blinkered I sometimes am when I think about systems, and I always talk about everything's connected, but I never think about the oceans. It's just not part of my frame of reference, and reading this study just made me think, if we're thinking about systems, we've really got to think about those large-scale planetary systems actually, and the unintended consequences across them. So thank you for adding your passion for oceanography into the mix as well, really, Vera. It was wonderful to hear. So we touched on modelling there, and that kind of nicely segues into our third topic. So for your What's Possible item, you wanted to talk about how artificial intelligence is starting to play a role in informing the public about the quality of bathing waters. So tell me a little bit more.
I thought it would be really interesting to talk a little bit about bathing waters, which are an area of such intense public interest, and link it up to the AI developments that we've seen in recent years, which are really sort of changing all aspects of our lives. So there's a huge interest from people in terms of wild swimming, but also enjoying bathing waters as spaces for recreational purposes, so for example sports, or just a place to visit. We know that beautiful blue and green spaces and healthy ecosystems have such an important effect on our well-being, and also the prosperity of our communities more broadly. And the government has really sort of responded to that public interest and has made it a key priority to clean up our rivers, lakes and seas in its latest plans. And there was a real increase in the number of designations last year. So there were many new designated water bodies, in particular river sites. For me, this is fantastic. It's really interesting to see that interest. I grew up in Greece and I really enjoyed swimming in the sea throughout my childhood, and it's such a brilliant thing to do for our well-being. I think it's important to note that overall bathing water quality has really improved since the 1990s. There's still so much to do, but the latest results indicate that 92% of our bathing waters meet those minimum standards set in the relevant directives, and 64% meet the excellent standards, so that higher standard of bathing water quality. And this compares to a number of about 28% of water bodies that were meeting the minimum standards back in the 1990s. So there has been, thankfully, a dramatic sort of improvement, but there's still a lot we can do. And I think we should be all, of course, striving for better quality across our coasts and rivers. And it's really wonderful and heartening to see the active engagement from such a broad range of stakeholder groups in this field. There are many organisations, many initiatives that are really working towards improving bathing water quality and also monitoring. So I think an important element of the story around bathing waters is notifications to the public. So everybody wants to be informed. Everybody who enjoys these spaces wants to be informed about their quality. At the moment, that's currently happening primarily in the form of signage on beaches or by the side of the bathing water body if it's a river or a lake, which is usually about a week sort of later than the samples were collected. And there are a number of trials at the moment by water companies and a range of organisations to explore how AI and digital platforms are able to help us provide more real-time notifications to bathing water users. And it's really important there to also learn from what other countries are doing, other countries in Europe, but also further afield, draw elements of that best practice, which is so important to people. And then secondly, in terms of technological advancements, there's also advances in the field of microbiology. So at the moment, bathing waters are monitored for E. coli and intestinal enterococci, which are really good indicators of fecal pollution that can come from sewage or, for example, farming and other sources. So they're a really important indicator, but they give us a relatively narrow view of that microbial picture. They give us an idea of the health risk, and that's how they have been developed. But we have so many new technologies now in the molecular biology field to get a more comprehensive picture of water quality. For example, look at viruses and also exploring the risk of antimicrobial resistance in bathing waters, which is something that quite a few research groups are looking at and the public is very interested in. So overall, I think the bathing water space is an area with some fantastic opportunities to combine those technological developments, AI being a key one in this space, with that collaboration and that engagement from stakeholders. So those two things going hand in hand. And there is some really excellent citizen science as well going on in that space. For example, at Ilkley in Yorkshire, and we know that citizen science can play a really key role in complementing the regulatory data and help us move towards that common goal of having better water quality and improved ecosystems.
We've loved being joined actually by Earthwatch and by the Rivers Trust to do two really big citizen science programmes as well. And it's definitely been an eye-opener to me just how many people are engaged actually with citizen science. And it's fascinating, I think. I know when we were in the middle of COVID and we started to look at COVID RNA in sewage samples, and you started to be able to track, viruses and understand public health from the treatment of sewage. And I guess in the same sort of way, river health is an indicator of all sorts of things, isn't it? Population health often can be seen by the health of our rivers. So it's absolutely fascinating. I think the more we study, the more we gather evidence and then use technologies, as you say, like AI to then help us solve some of those really big problems quite quickly, the better. So gosh, there's a lot going on. Thank you so much, Vera, for sharing all of that with us. You've given me loads to think about. I'm sure you've given our listeners plenty to think about as well. And we'll put links in the show notes to all of the things that we've talked about today if you want to find out a little bit more. That is all we've got time for, though. So thank you for joining us on our mini pod. You can subscribe to Planet Possible wherever you get your podcasts to never miss an episode. And you can join our mailing list to be the first to hear about new episodes. We've got more fantastic guests and topics lined up for the rest of the year, and I really hope you'll join us for those too. All that leaves me to say is a huge thank you to my superb guest, Dr Vera Jones. Thank you, Vera.
Thank you very much, Nikki. It's been wonderful to take part in this.
Well, that's it, everyone. Stay curious, stay connected, and we'll see you next time.